Let's see. Right. Right. Good afternoon, gentlemen.
Good afternoon, sir.
Afternoon, sir.
Okay. Good afternoon. Yeah, we what I want to do today would be, well, screw fasteners, but mainly nut and bolt, because this would be one of the constructions that you're gonna have to use um when you're putting things together. We're gonna do rivets. Rivets aren't normally they don't always ask for rivets. Rivets may come as part of your sketching or what you may use to hold together. We know what rivets are, right? Um, like in the back of some of the chairs, you may see a circle or something. Anyway, I'll bring the pictures of a rivet um, soon. Right, what we have on screen here, this is a bolt. All right, the bolt here, sometimes you may have a plain portion or you may have a threaded portion. We did how we draw the screw threads in technical drawing last day, right? So this portion here, one is plain, this is the threaded portion. Now the bolt would normally go with a nut. The nut would be come here and you will screw this up. Alright. I'll send something with screws and washers and so on, but what we're dealing with today would be the nut and bolt. Now you all got, oh boy. Did you all get, I sent something earlier on. Uh,
Yes, sir. But sir, did you send a recording from the last class?
no. Alright, you sent you one show. Alright, I'll check it out. I'll send it. Nut and bolt exercises, nut and bolt. All right. Well, last class was Monday or Tuesday.
Tuesday, we was doing the assembly drawing.
It's
All
Tuesday,
right,
sir.
Tuesday. I'll check back that and I'll do that for you all and send it later. Cause I think you all will need this one also. Oh, it's not this man. Ah, open reset, nut and bolt, nut and bolt. Nut and bolt. Let's see if it's this one. You have this nut and bolt. You have this nut and bolt. And I'm gonna check our next nut and bolt. Hey. Oh, nut and bolt revise. Had to be this one. Right. Now what happened why is that in the English version they would have they would give the distance of the bolt as D, but CXC you would have it as M. Right? Now oh did I have it on? In Trinidad, we get our size from the size of the head. In other words, if they ask you for a 12 spanner, you know what a 12 spanner is? Or so whatever spanner they normally tell you a certain size of spanner, a 15 spanner, they are talking about the distance from one flat side to the other flat side on the head, right? But in engineering terms, when you are given the size of a bolt, you are given the size of the shaft itself, the size from here to here, the size of the threaded portion, right? And in CXC, that is given as M, right? So let's say you have to draw a bolt M10, right? So I don't know if you could watch your figure, or if you have the figure, I would try to leave it here. But what happens with the AutoCAD is that, what happens there? I want you to open man. What happened with AutoCAD? I don't see all the features of it, but I will try. I will try. Right. We are going to draw a bolt M10. Now the first thing to do is to get the hexagon. Now in bolts, if you have a square bolt, in other words, if the top here is square and there are four sides, sometimes it'd be difficult to use in a small space because you're gonna have to get a whole 90-degree turn to be able to move it. And if you have an eight-sided figure, it could be easily damaged or rounded off. So the most popular size that is used for bolts would be six-sided figure or hexagon. Now we are given the bolt M10, right? So in other words, the size of the shaft here is 10. The first thing to be to draw a circle. We can draw the circle. How do there are two ways you can draw the circle. You can draw a circle and put the hexagon inside the circle. You could draw a circle twice M and put the hexagon on inside. So let's say we have M10, the diameter would be 20. So you could draw your circle 20 and put the hexagon on the inside of that. But we are using AutoCAD. So what we can do is to draw polygon. First of all, let me get the center lines. Any questions so far? Oh boy, this is not a normal drawing file. This is not a normal drawing file. Ow, ow, ow. Let me try the insect then. All right. This one all might give trouble. I'll get a center line. Oh, this is already too light. Draw a center line. You'll see in that line.
Yes, sir.
Right. You draw, we want the hexagon on the inside of the circle. So we go to our polygon. How many sides do you require? You type 6. Enter. We're going to do specify the center of the polygon. So we go with the center being here. All right. Do you want to inscribe? Do you want it inscribe, in other words, inside the circle? Or do you want it circumscribe the circle? Inscribe the circle mean that it would be the hexagon is going to be inside our circle. So default is I, but you can still type I and put enter. The radius of the circle, let's say our radius is M10. So what we'll do is M10, we'll try 5. Ooh, shaggy. Oh. Cancel. See if I have my whole screen, I'll find it easier. All right, so this now is our hexagon. Right? We said it's M10, so you draw your circle 20. So if we measure this, you'll see from here to here, it's supposed to be 10. No, it's supposed to be 20. My God. Let's draw a circle again, the hexagon. M10, so you join it twice. Polygon, 6 sides. We want the center here. And we put in 20. I enter. Yeah. We go 20. Something wrong again. What am I doing wrong? From here to here, not 40, 20. All right, let's start over. The M is 10. So therefore you draw a circle twice. I didn't draw the circle. No, in the good old days, we would have had to draw the circle and put the hexagon on the inside of it. But as much as you have AutoCAD, you put the hexagon on the inside of that. You put the hexagon on the inside of it here. Radius and so that here. Right, so your hexagon would be on the inside of a circle twice times M. Once you have your hexagon, you then move on to draw the elevation of it. I don't like these colors. So
So how many circles does it have in that?
for the we started with one, right? We
Okay.
started with one, but I don't like the way these colors coming out, so I have to get something here. Let me get something here quickly. Mm, okay, you paste this. You see our center line is coming up here. I think I could remember this, you know. But let us center line still light. Yeah, the center line too light. Anyhow, you're seeing the center line? Let's change the cell construction.
Yes, I see center line.
Okay, no problem. It changes cell construction. This circle here is a construction. Right? So we are dealing with M10. So from here to here is 20. You put your hexagon inside there. What you do from here now is to draw, you have a light line there already. And draw a line. Well, depend on what drawing you're doing, you'll know this line. You know what distance to put your line. All right, this will be where your bolt will be starting. It's just the head of the bolt. You join the rest of the bolt here. Now we have the height of the bolt is 0.7 of m, right? And the nut would be 0.8 of m. So in order to simplify the drawing, what I would recommend for when you're doing this drawing quickly is to use between 0.7 and 0.8 is 0.75. So if our height is 10, if our m is 10, 75 of 10 would be, we'd copy this 7.5. So the thickness of the bolt and the nut, we'll use both of them as 0.75, right? And now we would draw lines going up here, a line going up here, a line going up here, and one, oh, remember you could press enter and you get the same thing. So this would be our three sides for if you're looking at the bolt from this direction. Now, in order to get our curves on the bolt, what we do is to draw a line from the corner here, 60 degrees. This is 45. Oh, what we'll have to do, set our polar tracking at 15 degrees. So if we come here, we could get our 60 degrees here. If you do the same thing on the other side, you'll get 60 degrees here. From this, use this point as the center, and you draw a circle coming down to the end here. You can then trim this, trim between here and here, and this will be this curve at the top here. Right? So you go 60 degrees from this corner, 60 degrees from this corner, and where they meet, from here to here, you'll draw this curve. Now, again, to get the smaller curve, all right, you draw a line 60 degrees again from this corner, 60 degrees, And from here, you do the same thing. You draw a circle. From here, you use this. Oh, it's still on line, man. What I'm saying. Now, this is an approximate method. From here to here. And this should be our lighter curve. And we trim the same way. Now you could do the same thing on the other side, or you can mirror the thing. Mirror this curve, and bring it here. So this would be our nut. No, hey, you didn't mirror yet? What I'm saying? I want you to mirror on. Mirror this curve. It's an approximate method. As if you're going real close, you may see that it may not be exactly any point, but once you darken it, that should go there. Now the thing is, in order to, as a safety feature, what happened with these nuts is that if you put the corner here square, it could be very sharp and dangerous to use. So what is done is that they smoothen off the edges. So you will see a circle from here to the edge of the hexagon. If you well, there's the problem with the online thing. If you check any bolts, you will see that there's a circle at the top, and these corners here are sloping. That means there's a 30-degree line, going this way. 30 degrees, a 30-degree line from there. This line here is, I wonder if it's here, is 30 degrees. Again, we could mirror this. And you would join this, draw a line from here. What this mirror thing on? Mirror from here to here, enter. All right, so this would go straight down to here. Let us feel it out. This line and this line. Right, that this comes about because on your nut, on the end of your bolt, this is the flat portion, and this small portion here is always slanted down to avoid the sharp corner. But if you look at the bolt from the other side, you'd realize that it would be square because the circle meets the edge at this point here. So if we're using our knowledge of orthographic projection, if we have our 0.75 of m, let's use a 45-degree line. Let me get some construction. I remember my whole screen, yes, this thing keeping me back. Some construction lines, you draw in from here, from here. And you carry this up, and you carry this up, and you carry this up. So if you're looking at the nut from on this side, the bolt, sorry, from on this side, it's going to be totally square. And you have a line for the center portion here. No, using our in the good old days, we had some construction to use for AutoCAD. Where do you go? You can use some construction to get this curve here. The radius of this will be same as m. So what I do, if you find the middle of this side, that one be the middle of this here. Oh. You normally draw a nice construction line. Find the middle of this line. Way down to here. Carry it up. And you're using 10, radius 10. Center circle, center radius. You see as the center, radius 10. Right, now you can draw a circle, same 10 from this point here. And that would be your curve on the end view. And again, you could just mirror the stuff and you're good to go. This here would represent the head of the nut or the bolt. Right? Remember, the first thing to do is to you'll be given M. M would be the size of the M is the size of the shaft. Right? As I was saying in Trinidad, they give you the size of the bolt, but for the technical and mechanical purposes, once you are given the size of a bolt is M something, M10, M20. So all dimensions would be done in relation to that. So from here to here would be 10. And to get the hexagon, you draw a circle twice times M and put the hexagon in that circle. So once you have this hexagon here, that would be this light line here. You go to your polygon, you do your 6 sides, you specify the center where it is, and you draw an inscribed hexagon. So you just put your twice times M, and that would give you this light circle on the outside here. Your hexagon will come upon that. Now, for drawing purposes, the height of the bolt is 3/4 of M, which is 3/4 of our 3/4 of 10, which is 7.5. So from here to here, 7.5. You then use your knowledge of orthographic projection to carry up your lines. From each corner, you go 60 degrees where it meets here, the center line. From the center here to here is where you draw this curve. And to get the smaller curve, from this corner here, you go 60 degrees again, draw this curve here. Where it meets here, you come 30 degrees. From here, you come 30 degrees and you join from here to here to get our view that will show 3 sides. If you want the view that will show 2 sides, you draw your 45-degree line. We just have one error here. There's no line here. Right, that stops there. Right, you take M, find the middle of one side, you take M from here. So from here to here would be 10. And you draw a circle radius 10 and you trim it to suit. All right, any questions on this? Now, why I want us to, well, let us see if we can have this, because the thing is, with this here, all right, with this here, come now, man, what I'm saying. Anything want to come across? Or if you want me to grab you, I'll grab you. No, I am going to grab you. No, it's taking his time. Right. What I want you all to do is this 10 here, right? If we have, oh God, come on, man. Sometimes it's giving trouble. If you have a bolt to draw, let's say your bolt is 15, you can take this. If you do this 10, right? You can take this, let's copy this. You have a bolt 15 to draw. You won't need all this, just, then you could always draw back the center lines. Let's take up all the rigmarole. Right, you have a bolt 15 to draw. All you have to do is scale this up. If you have 10, how are you getting 15? Multiply by somebody. Hello?
Wait, say 50 or 15? You said?
15, 1 5. This is 10. You want to get a bolt 15.
Multiply by 1.5.
Right, so you scale it up. You do the scale. Select everybody. You monk for those two lines, but I'll put them in any case. Right, scale, select objects, enter. Specify the base point. Let's say the base point is center here. And the scale factor is 1.5. Enter. Right, so you'll see now your circle here would be twice m, which would be 30. So from here to here should be 30. So once you have this here as 10 on your computer, you should be able to draw any bolt, any size. Right, let me see if it'll come across now. Right, lovely. So if I give you this exercise to do, right, you can draw this head here. This is a M12 bolt. So you'll multiply by 1.2. What we are saying is that this bolt is M12, is 50 long, right? Now, when they say the bolt is 50 long, go back to Mendelssohn bolt. When they give the bolt length does not include the head. So if the bolt is 50, from here to the end of the bolt is 50, right? Oh, this is the M. This is D, sorry. All right, yeah. From here to here would be 50, all right? Now, as part of the detail, this here is the threaded portion of the bolt. Where we see these two lines, remember I told you that the outside line was dark, the inside line was light. Now, the formula is m/8. Now, normally I'd put this as 1 or 1.5 millimeters. Now, 10/8 is 1.2 or something like that, right? So for drawing purposes, you could use 1 or you could use 1.5. And to end it off, they normally have 60 degrees here for where the thread will start. Now, in this problem, they did not give a length for the thread length, because the thread length would be the length where the threads are. This portion here would be a unthreaded portion. Now, in this case, washers are normally 2M, but in this here, they give you the size of the washer. The washer is 36 OD. What the OD means outside diameter. Right now, washers are used to save the material, or so it wouldn't damage the material. Right? A washer is normally it's a softer material than the nut or bolt. So the washer is used to safeguard the material. Because if you're tightening this, if you over tighten it and it's material alone, this piece here will damage it. So they'll put a washer. In this case, our washer is 36 outside diameter. So the outside diameter from here to here is 36. The size of it is 2. Right, so
I have a question.
yeah, go ahead.
What if they don't give us the height of the washer? They say it's to the west. What if they don't give us anything?
No, you
What's
well,
it?
as I was saying, CXC, anything they don't give you is up to the candidate's discretion. Is your, it will be your choice. But you know, the washer is not normally that big. It's about one or two. Washer can be more than five. All right, now I'll send this for you. So I want you all to do, first of all, do do one of these, and you make call this 10 volt. So you'll always have this on your, always have this on your system. Right?
So
Do
once
this,
we draw the 10, we could
send
always
this
select
some
any
here.
other size.
Right. You could use the whatever they give you. Like in this case, you want a 12, so you just scale this up 1.2. Right? And the thing is, remember that these two circles here, one is for, this would be the 12 will be the outside line, and you could just offset the other one, well, 1 or 1.5. Right? Now, one more thing I could show you here, that this year they have some oil. To get this curve, they use 1.5 m. But the faster thing to do is just to draw a 45-degree line, or draw a line, a 45-degree line from the end of the thin lines, and you square it off like this. Or you could use 1.25 m as this radius, so you can get a curve here. So you could use any one of these ends to draw the end of the bolt. Right, so you think we could do this and then try this? Any questions on the previous exercise? Yeah, sometime here.
So just like this class is being sent as well, right?
This?
Yeah, the recording for this class.
Yes,
Oh,
sir,
yeah,
if
well, yes, I'm supposed to do, we'll do both of them.
yes, sir, these two would be helpful.
Yeah,
Yeah,
well,
because
these things that, but no, yeah, I don't expect you to get this right away, because I know, well, your teacher is supposed to do, some books with you. Right? The thing about this, I normally have a big bolt, pass around so you'll see it. If I find it, I'll take a picture and show you all how the heads are. Unless when you, if you're going down in traffic and you can look at the bottom of those traffic lights or any of those lights, they are there are some very big bolts that you could actually see how some of the heads are, because it's very difficult to see this smooth thing here on a small bolt. The idea is to do this. This is the hardest thing. Well, the hardest thing they could give you when you're putting some things together on your drawing. Right? And once you have your nut or bolt, that is where a lot of the marks would come in when you are doing these machine drawings. And if you're doing an assembly for your SBA, once you put in a bolt, they know you have some knowledge of technical drawing. In a way, screws are basically the same thing. Right? Is there the difference in the screws will be the size of the head, and you will be doing machine screws instead of wood screws. I'll show you all. I'll give you all some diagrams on those. Right, but the main thing would be how to draw a bolt. So I would have sent the paper on how to draw it. I'll send this one. No, this one. You should have this one, right? In some books you may see D instead of M, but CXC uses M. All dimensions are in relation to M. And I said this here, the nut is supposed to be slightly bigger, because this will be the one that's being removed and put back all the time. But for drawing purposes, to be able to remember it's 3/4 of M. Between 0.8 and 0.7 is 0.75. So the height of it is always 3/4 M. This will be 3/4 M, this will be 3/4 M. And you use a 60-degree lines to be able to get this curve. All right, I have to make sure and yeah, but I'll do these. Better do these now. One was from Tuesday and today. I think no. Oh no, I think I asked you on Tuesday. You weren't sure, but no problem. I'll organize it Tuesday and to organize this one also. Right. Do you think we could try this? Well, I will send this.
So
I'll
I have a
send
question
this.
about the same drawing we just did, right? I seen
You,
on the paper you had like it had an extra set of
extra setup.
like I seen some other stuff than what you draw on AutoCAD. What's
What
all
are you
those
talk,
other stuff?
we're talking about?
So you see what you drew on AutoCAD just now?
Uh-huh.
There's some
No,
other stuff.
all I did was here. All I did was this.
Oh, okay. So we'll
Yeah. What? Something went wrong. You hear
Yeah.
me?
Yes, yeah.
yes, again you.
Yeah. All right. No, all I did was this. Now this here, from here to here is the bolt. Right here is the bolt length, and here to here is the thread length. Because well, in this here, they gave you the bolt 50 long. That I told you. When I say 50 long, it's from here to here is 50. All right. And these, remember last day we did these lines. What these lines were about. This is the threads would be here. The zigzag thing would be here. So you just join them as one line. One for the outside and one for the inside. Remember, for drawing purposes, we could have this space here as 1.5. Very good, very good, very good. Right. So from here to here would be 50. From here to here is the bolt length, and from here to here would be the thread length. Now, in the question, they did not. I did not state. Oh, sorry, it was not stated what the thread length is. They just gave you the bolt length. It's up to you to put this where you think it should go. So we could continue on this here because and the thing, why did put this washer here? This washer was put in midway between here. This is just to show you where the washer, the size of the washer, how it's situated. Right? But in this case, our washer is against the material. So when you put it together, your washer should be against the material. This is just to show you how they got the size of the washer. Now this washer is 0.2 m. So in other words, this washer for 10 would be 2 millimeters. But again, these things are not really arbitrary, but this is the formula for it. But if it's smaller or bigger, it's not a problem.
Okay, so I understand.
No, you could check it through, watch it and see when you're drawing it, then if you have your questions, then you could email your questions so that I could address them on the next class. But the main thing is to be able to draw this portion. Here's the hardest portion. The head, the elevation, and the two elevations.
Okay, so I saw you emailed my mom to ask me about like how it's going and stuff. It's beneficial for me and like it's really helping me. So yeah,
I just
classes are
don't want
good.
to be in too much conflict with your class teacher because not every teacher um is anyhow. That's the next story. Now, when they come to teach this, they may use a slightly different method, but this I find this method is the fastest to be able to work with. All right, and well, you see which method they will have. Oh, it's almost less than a minute. So I'll try to send the videos later for you all this afternoon, and we meet again on Monday. Monday or Tuesday?
Tuesday.
Tuesday, sir.
Tuesday, yes, Tuesday. All right.
So sorry for the slight interruption there. No trying to bother, man.
No, well, remember last day my grandson came in. He didn't know I was in class. These things happen.
Yeah.
All right. So we have to go through more locking devices and so on, like screws and so on. Uncle Bull. So all right. Enjoy the rest of the day and the weekend. I'll send the videos for you all later. Okay.